Hello, it's Technology Central here, formerly the IT Guys 99, and welcome to this tutorial on how to use the NumPy module in Python. So, NumPy is a module which will add multidimensional arrays to Python. To follow along with this tutorial, you should already have a basic understanding of how to use Python. If you don't have that, please go and watch our tutorial on a beginner's guide to Python right now, and then come back to this tutorial. You'll find a link to that video in the description or on the card on screen. To use this tutorial and use NumPy, you'll also need to have NumPy and a version of Python installed on your computer. I recommend using the Anaconda version of Python, which will come pre-installed with NumPy and several other useful modules such as pyplot. You can also find a link to that video on our channel showing you how to install the Anaconda version of Python in the description or on the card on screen. If you don't want to install the Anaconda version of Python and you instead just want to install the basic version of Python, you can follow along with our tutorial on how to do that, and then use pip to install NumPy by typing pip install NumPy on the command line. Now once we're set up, we can begin this tutorial by looking at why we want to use NumPy. So NumPy will bring multidimensional arrays. These are useful for storing many different pieces of data in a single element or single variable. It's also very easy to manipulate these arrays with different mathematical functions. For example, we can multiply two arrays together, add two arrays together, or perform mathematics on a whole array in one go, rather than having to do it each element like you would with a Python list. And also, by using NumPy, we can do these manipulations much quicker than we would in a Python list. We can specify the data type that we are using within our array, including how many bits should be assigned to different integers or floats. This means that we can significantly reduce the amount of memory our program is using as well. Now let's have a quick introduction to multidimensional arrays, and then we can jump into the code. So each array will have a shape. The shape is specified first going back in the backwards dimension, so the z-axis, then the y, and then the x, or in this case the i, j, and k directions as shown in the diagram. So for this example, we have three arrays going back vertically, so it will have a shape of 3. It has 4 elements vertically and 3 horizontally. So it would have a shape of 3, 4, 3. We can also access each specific element within the array by looking at its index. So the index of this red square is 0, 1, 1. In Python, we always count from 0 in the indices. So for index 0 is going to be this first array. Then we have the second and third arrays going back. It's also vertically in the first row. So we have row 0 and then row 1. So it's in row 1. And it's also in column 1. So we have column 0, then column 1. So its index would be 0, 1, 1. Similarly, this red index here, we have it in the third matrix back, which puts it index 2 for the I direction. It's in the first row, which puts it at index 0 in the j direction, and it's in the second column, which puts it at index 1 in the k direction. So it would be at index 2, 0, 1. Now we've got a basic introduction to the NumPy arrays. Let's jump into the code. Now we understand the importance of NumPy, let's import the module so we can start using it in our code. To do this, we first type import NumPy, like so. NumPy is quite a long word to have to keep typing within our code. As programmers, we like to make things as easy as possible, so we will often type as np, as this will mean that we only have to type np every time we want to use NumPy instead of the whole word, which just reduces the amount of typing that we have to do. Now we can save this, and when we run it, it'll take a second to import NumPy, especially the first time you run the code, but then after that we'll be set to go. So we can see that we haven't got any errors, so it's successfully imported NumPy. Right, let's now start by creating our first NumPy array. We declare our arrays much like we would a variable in Python. So we can start by typing, for example, A equals to call on an array A. And now we're going to first start by using the array function within NumPy. So the array function is written like this, and we're going to be using the NumPy module, so we have to type np dot at the start. This tells Python that we're using NumPy and that we want to use the array function from within NumPy. So now we've written out numpy.array, we need to give it some values. The first value we give it is a list of variables that we want to include in our array. We do that by giving it some square brackets and then typing our variables like so. This is just going to be creating a one-dimensional array to start with. We then put a comma, and then if you want to specify a data type for your array rather than just using the default, you then type dtype equals, and then you specify the NumPy data type that you want to use. For example, you could use numpy.int32. This means that you're going to have a 32-bit integer, so each integer within our array will take up 32 bits of memory on your computer. You could also use, say, int64, which will then create a 64-bit integer. The default data type, if you don't specify it, will be an integer, and on Windows it'll be an int32 because that's the default of your system. You could also use, say, float32 if you wanted a float rather than integers here, or bool if you wanted Boolean values, so true or false, in your array. I'll leave it as int32. Now we can just come down here and print out our array A. Now when we come to PowerShell, we can run our code and we can see that 1, 3 and 5, which is our array, have been printed out. Now let's create a slightly more complex array using this function. I might want to say create a two-dimensional array. To do that, I'm going to include a second set of brackets within the first, separated by comma. So this is going to be like the first row of our array. This can be the second, like this. And then they're all within this bracket. So this is basically us typing out our array. Now when we run this and we'll then print out our array, we can see we've got 1, 3, 5, 7, 9 and 11 as our two-dimensional array. Similarly, we can keep adding sets of brackets separated by commas, moving deeper and deeper into the array to create higher and higher dimensional arrays. Now let's have a look at a different method of creating an array which doesn't require us to type in all of the numbers manually. So let's delete this. And again we'll keep A. And again we're going to use a NumPy function. So we're going to type np. But this time we're going to type in zeros. What this will do is it will create an array filled with zeros. And now the parameter that we need to include is just the shape. The shape we're going to pass in as a tuple, which means we put this set of round brackets here, and I'm going to give it a shape of 5, 3. Now we're going to print A, save our code, and now let's run it. And we can see that we've got an array which has the depth of 5 and a width of 3. So we have our shape 5, 3. And it's all been filled with zeros. Just like this zeros function, NumPy has a ones function. So I could also change that to be, say, ones. And now when we run the code, we'll see that we've got the same shape array, but this time filled with ones. We can also then specify the data type, like we did before, by including a comma, dtype equals numpy.int64, for example. And now when we run it, all of them will be an integer 64, which you can see here. They no longer have their decimal point, and that's because they're no longer a float. Now we're going to look at another way of creating our NumPy array, and this is going to be using the arange function. Again, we're going to start by typing np for NumPy. Then we're going to type a range. Be careful to type a range rather than arrange. There's not two R's here. Now we're going to end the brackets. Now inside here we need to put a starting value an end value and a step. For example, if I start off at 2, I end up at 10, I go up in a step of 2, we'll expect to see 2, 4, 6 and 8. Remember, a bit like the range function in Python, this doesn't include this end value. So you'd have to include a higher value if you wanted to include 10. Now we can just print A as our array. And let's run that code. And we can see we've got 2, 4, 6 and 8. Now that we've printed A, what we're going to do is we're going to look at how we can reshape this array into a different shape once it's been created. To do that, we do this after it's been created, and we're going to come down and say a.shape. And this is just accessing the shape property of this NumPy array, so we don't need to specify NumPy again. And then we're going to set it equal to say 2, 2. So this is going to be specifying each dimension individually. Now when we come down and print A, let's have a look. We can see it's now been reshaped to be 2, 4, 6, 8, like so. This is important that we have the same number of elements at the end in our reshaped array compared to the array we started with. We're not adding or removing elements when we reshape it, so we have to make sure we keep it the same. There's another way that we can reshape A, which is what we do on root creation, where we type .reshape, and now inside this brackets we're going to specify a tuple for its new shape, like so. So we've got these double brackets with 2, 2 inside. And now when we run the code, again we see we get the same result. Now let's have another look at another method that we can use to create our arrays. So this is the numpy.linspace function. So again we're going to start with np, and this time we're going to type linspace. So this function works a bit like a range, however it has a different trick to it. So again we're going to specify a start value and a stop value, but instead of specifying the number of steps, we're going to specify how many elements we want in our array, and then NumPy will distribute all of the elements evenly between the start and the stop value into the number of elements that we specify. So for example, again, if I type in 2 and 10, and I tell it that I want 10 values, or if I specify 1 and 10 might be a bit nicer. And now if I print A, what we're going to get is we're going to have 10 values starting at 1 and ending just before 10. So you can see we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So we've got the 10 values that we asked for distributed evenly between 1 and 10. If I reduce this to 5, we'll only get 5 values in our array. So you can see we get 1, 3.25, 5.5, 7.75 and 10. So they've been equally distributed, starting off at 1, ending at 10, with an even step between all of them. Now we have created our array. I'm going to stick with this array, and I'm going to look at a couple of the other properties that we can access within this array. The first one is going to be looking at what the shape of the array is. We do this with the a.shape function, like so. But rather than specifying a value, we're going to print it out. So let's run that, and we can see that it has a length of 5. I'm going to change it back to 10, not 510, just 10. And I'm going to reshape it into 5, 2. So I'm going to change its shape, and now when we print a.shape, we'll see that it'll have a different value. So see, we can now see that it's got 5, 2 as its shape. We can also print its data type by printing a.dtype. And we can run that. And we can see that we're currently working with float 64. If I come in here and then specify dtype equals numpy.int32 and then run it again, we can see we're now working with integer 32 values it's very useful to be able to change and check what data type you're working with, especially if you're working with large numbers, as sometimes numbers can reach a point where they're larger than the maximum value that can be stored in, say, a 32-bit number, and that's where you can get overflow errors occurring. So we've learned how we can reshape our function. I'm going to change this back to shape just because there's also a function called flatten. So this is when, if we want to go from this multi-dimensional array and move it back into a flat one-dimensional array. So again, I'm going to say A is going to be A.flatten. And what this will do is it'll just convert this two-dimensional array back into one dimensions. As we can see, we're now working, and it's now 10, and it's all one-dimensional. Just print A just so you can see. I'll print it before and after we flatten it. So you can see that we start off by having it 5 long and 2 wide, and it then becomes this one-dimensional array when we flatten it. I'm going to get rid of this, and now I'm going to say that I'm going to look at how to use the numpy.transpose function. So I'm going to say A is going to be numpy.transpose, and it's going to just be the transpose of A, and I'm going to print A before and afterwards just so you can see the difference, and we'll run that. So we can see that we start off with it being 5 deep and 2 wide, and now we've just got this array transposed, so this first column becomes the first row, like so. Now we've looked at sort of how we can manipulate and create some of the arrays, let's look at what we can do with multiple arrays, and look at how we can do some mathematics on our arrays, which is where where the power of NumPy really comes into its own. So I'm going to create a second array. And they're going to have this same shape. Now I can print A and B. So we can have a look at them. So we can see that A is this nice 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and B is horrible a minute. So let's have a look at what we can do. Let's make that 50. I think that will make everything a bit nicer. Yeah. So A is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and B is 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. This not coming onto a new line is because we have them both on the same print function, so it started to print one after the other without a line break. So now we've got these two arrays, let's see what we can do with them. We can do A plus B, and this will add all of the elements from A into B. So this 1 will get added to this 5, this 2 will get added to this 10, and it'll create a new array. So let's run that. So you can see that we've had 1 plus 5 is 6, 2 plus 10 is 12, etc. to create this new array. Now this runs much faster than you would say with a Python list, where you'd have to loop through all of the elements in both arrays and add them individually using a for loop. By doing it with this matrix addition, it's much faster to do this sort of process. You can also multiply by doing putting a times here. And as we can see, we've now multiplied them two together. So 50 times 10, for example, is 500, which is what we've got here. We can subtract. And as we can see, we get the negative answers here, which again correspond to, say, for example, where have we got to? Yeah, 10 minus 50 is minus 40, which we can see there. And we can also divide. And run that, and we've got these answers which are all actually correct, and it's given us these floats of 0.2. So now we've seen how we can manipulate between two arrays. We can also just manipulate one. So I can say print a plus 10, and this will just add 10 to every element of the array. So you can see 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20, where this was just 1 to 10 before. And as again, we can do the same sort of principle with multiplication, subtraction, or division. There's also a way of doing a matrix multiplication. So matrix multiplication isn't the same as just timesing every element together. If you've never done a mathematics course where you've seen matrix multiplication, then you won't need to worry about the next bit. But if you have, and that's what you're trying to do with these two arrays, then we can do that by typing a dot, then we type the word dot b. So this will do the matrix dot product between a and b. And we can type that. So to do a matrix dot product, we need these to be in the correct format. So one needs to be they need to be either a square matrix or sort of the opposite shapes to each other. So 5, 2 and then 2, 5 should now work. And there we go. This is now the matrix dot product that we have after doing our operations. Next, what we're going to do is we're going to get rid of this, and we're going to look at some of the other maths functions that get added to Python using the NumPy module. So first of these are the trig functions. So if we want to print, say, the sign of pi, so we can type in the print NumPy, it's a NumPy function, dot sign, and then pi is also a NumPy function, so we can type NumPy.pi, and it'll include the value of pi. This is us using radians. And as you can see, we get a very, very small number. That's because the sign of pi is approximately 0. So when it goes to this very large floating number, then we never quite get 0 while using computers. Instead, we get something which is to the order of minus 16. Similarly, we can use numpy.cos of pi, and this is -1, which is coming out correct. I'm not going to do the tan of pi because that's not going to work, but that is an option. If I say do pi by 2, then we get this very, very large exponential number. Tan of pi by 2 is a very large number. We can also do numpy.square root and numpy.exponential. So again, we can do that by doing numpy.sqrt and say if I include 4 there, and we'll get 2, and numpy.exp of 4, it's going to be e to the 4, which is 54.598. So the power of this might not be obvious initially, but we can also include arrays in here. So if I type in a equals numpy.ones, I'm going to have it being a 4 by 4 matrix, and I'm going to multiply them all by 4, and then we're going to print the numpy.the square root of a, and I'll print out a as well just so everyone is clear what we're doing. So this will just give us a 4 by 4, a matrix of the number 4, and then we're going to take the square root of the whole matrix in one go. So I should have just typed NP here. So we start off with this 4 by 4 matrix of 4s, and then it comes down to this array of 2s when we take the square root. And this is again much faster than the Python version, where you'd have to loop through each element within your list and then square root each of them individually, rather than doing it all in one go. So this is where the power of NumPy really manifests itself. And by also looking at this sort of thing, we can do some other maths features with our arrays. So for example, I can print numpy.min a to find the minimum value of a. I mean, in this case, it's not going to make much difference. It's always going to be 4 because the whole matrix is just 4s. But that's how we could find the minimum value. Similarly, we can find the maximum value like so. And we can run that. And the maximum value is also going to be 4 in this case. We can also find the mean, which again is going to be fairly meaningless here, but find the mean using numpy.mean, and again it's going to be 4. And finally we can find the standard deviation by typing std here for standard deviation, and we can run that, and we can see that we've got a standard deviation of 0. Next, we're going to look at how we can index and slice an array. So first, let me create a few arrays. Right, I've created an array, so let's just print that out so we can have a look at it. We can see we've got the numbers 1 through 9. Now, if I want to take a subset of that array, I can access it by indexing, much like we did with a Python list. So we do that by putting these square brackets. Now the index counts from 0, so this is going to be index 0, 2 will be index 1, 3 will be index 2, etc. If I just want to say take 2, 3 and 4, this will be index 1, 2 and 3. I'd do that by typing 1, colon 3. This means from index 1 up to index 3. So let's run that. And we can see that we get 2 and 3. This is because when it does the indexing, we don't include this final index. So if I went 0, 1, 2, 3, we don't include this one, so we just get 2 and 3. I can also say this to be 4 and include a step of 2. And now when we run that, we're going to get 2 and 4 because we're taking a slice from index 1, 2, 3, up until index 4, so that's 2 to 5, and we're going in steps of 2. So, and we're not including 5, by the way, so we're going to go 2 and 4. So it's going to go from this one, go up 2 to 4, then try and go up again, hit 5, this is gone to the end, and stop there. So that's where we get 2 and 4. Now let's create a slightly larger array, which has multiple dimensions. Okay, so now I've created this array. Let's run it so we can have a look at it. So we can see we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right then, so now let's have a look at how we can index it. We've got a shape of 2, 5. So the first index that we give is going to be vertically. The second index that we give is going to be horizontally. If we have a 3-dimensional array, the first index we give is going backwards, so depth. Then the second one is going to be vertical and the third one horizontal. So we're again going to just put our square brackets. Now this time what we're going to do is we're going to take this, we're going to look for this column 2 and 7. Okay, so first off, vertically we want all of it. To do that, we could just leave a colon in there and then put a comma. So this is going to be the first set of indexing, which is the first dimension, which is our vertical dimension, and we're going to want that whole dimension. So we just put this colon. Now we want 0, 1. So we want the first column. So as we go horizontally, we're going to want this first one on each row. So we're going to have index 1 here. So now let's run that and see what we get. And we can see that we get an array 2, 7, which is just that column that we were looking for. Let's do another example where instead we're going to look and take this 8 and 9 on this second row. So to start with, we're going to look vertically, and we just want the second row, so they're in index 1, because it's this first row here. So this row would be index 0, this row would be index 1. Now we go moving horizontally, We want 0, we want index 2, and index 3. So we're going to go 2:4. So remember that we want to go up to the one above what we want. So if we want these two, this would be index 2 and index 3, and then it'll go, so we say 4, because it will not include that final index. So this will give us indexes 2 and 3. So let's run that, and we get 8 and 9. Excellent. So now we've had a look at how we can index our NumPy arrays. And this is now also how we can take a slice of an array. Let's have a look at what happens if we try and manipulate this slice. So if I say instead make b equal to this subslice, and then if I say multiply b by 2 and print b, we'll see that we can do the same matrix manipulations on b. So we can see we've got 16 and 18. We just multiplied those 2 bits by 2. Okay, so we've seen that we can do manipulations on these subsets of an array like so. But there's an important thing to note here, so that if we now manipulate a, b will also change. So for example, if I come in here, and I'm just going to print a as well, and I'm going to get rid of this b times 2. So we're just going to set b equal to this part of array a. Now if I come here, and I'm going to change a, so I'm going to say a times equals 2. So what I'm going to do, this is the same as saying a equals a times 2. So I'm just multiplying a by 2. I'm going to print a again, and I'm going to print b again. And we're going to see that b will change even though we haven't changed it. So you can see that we've multiplied everything in a by 2 between these two, but b has also multiplied by 2 even though we haven't done anything to b. That's because when we take a slice of an array like this with NumPy, it's just a pointer back to the original array. So any changes that we make to the original array A will also occur to any slices that we have made. So that's an important thing to remember. If instead you don't want this to happen, you have to make a hard copy of the array. This will mean that rather than it just being a pointer back to the original array, you'll have a separate array in memory. To do this, we can do it quite easily. We just say c equals a dot copy. And now if we manipulate c, set b equal to the subarray of c, and do this manipulations, we'll see that b won't change. So we can see that even though we've multiplied our original array like so, b hasn't changed. So that's where we need to use the array copy function within NumPy. And now we're going to save this array. To do that, we're going to use the numpy.saveTxt function. So we type np.saveTxt. Then we're going to give it the first variable name, which is going to be our file name, which is going to be array.txt. Then we put a comma, specify the array that we want to save to the file, which is going to be array A. Now you can end it there if you wish, or you can specify a delimiter. And this one, I'm going to put a comma. You can choose what you want. If say a comma, you can create a CSV file, which means comma separated variables, which will let you then open it in, say, Excel. So now let's run this code. You can see that we have a printout. Then if we come in here, we've got a text document called array, which has 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. You can see it's got e to the 1 here, which makes it 10. You can also change the data type of your array. For example, I can put in dtype equals numpy.int32 in here. Just close this file. Run that code again, and now when we look at it, that will all be in the format of int32. We now want to look at how we can open these files again, now that we've created it. So we can do that by using the numpy.load txt function. We need to load it to an array, so I'll call it A. We then need to give it a file name, which is going to be array.txt, and we need to tell it any delimiter that we've used. So I'll put in a comma, like so. Now I can just print A, and when we run this code, it'll open that file and print out our array, like so. There we go. So that's everything that we think is important that you know about the NumPy module in Python. We hope you found that useful. If you haven't seen it already, go and check out our tutorial on how to use Python. And we've got upcoming tutorials on how to use pyplot, which will be how you can graphically plot and represent your data once you've got it into NumPy arrays. So make sure you subscribe for that. But for now, thanks for watching and goodbye.